In this video, we're just going to review some of the derivative rules from AP Calculus AB. So we start off here, you'll see, with some very, very simple derivatives like this one, f prime. We're just going to use the power rule, so 5 multiplied by 2, so the coefficient multiplied by the power, drop the power by 1. 6 multiplied by the power, remember we kind of imagine it's 1, so 6 times 1, drop the power, and of course the constant disappears. The derivative of a constant is 0. Zooming over to the right, this one will require chain rule because we have a function put inside of another function, okay, like this. So remember, we start with the derivative of the outside. The derivative of cosine is negative sine. We're going to leave the inside alone. Okay, I'm just going to kind of leave that. I'll fill it in. And we multiply then by the derivative of what was in that box, which is 15x squared minus 3. And remember, what is in here is just the original inside the box. I'm sorry, that's a little tight. But now, here we've got a product, right? We've got a function multiplied by another function. So if you recall, in product rule, we always do the first function multiplied by the second, or the derivative of the second, which would be the cosine of 2x multiplied by 2. So we need a chain rule there to do the derivative of the second. And then we do plus the second multiplied by the derivative of the first, like that. Now again, this is just review. If you've forgotten any of these rules, you might have to go back, you might have to ask for some help, and you could certainly clean this up. In the interest of time, I'm just going to leave it, but we could maybe, I could maybe clean this one, something like this. We usually like to have our power stuff first and our trig stuff last, like that. That would clean it up a little bit. Okay, zooming over here to the right, of course we've got a quotient. So if you recall, we do low multiplied by the derivative of the high. Well, the derivative of the high is just 1 minus high times the derivative of the low, which is 2x, cross the line, and square the low. So low d high minus high d low, cross the line, square that low. And you could clean that up a little bit. I'm going to leave it for the sake of space and time. Now let's go down here. Our final two, you'll notice now we've got x's and y's. This is what's called implicit differentiation. And this is an explicit function is one in which you can isolate a variable. You get down to just saying, oh, it's just like y equals, and it's only a function of x. Implicit means that you can't do that, and you've got both x's and y's. So if you recall from Calc 1, as we do the derivative, we kind of do a massive amount of chain rule here. The derivative of y is dy dx. I like to use Leibniz notation. Now, x squared y cubed, this is a product. Right? I'm just going to underline them. We've got a function and another function, so we're going to need product rule. First times the derivative of the second. And we have to use chain rule. The derivative of y cubed is 3y squared multiplied by the derivative of y, which is dy dx, plus the second times derivative of the first. Okay, and we do it again with this next function. You'll see we got a product again. So first times derivative of the second plus second times derivative of the first. Like that. Now, what we like to do at this point is take the stuff that doesn't have a dy dx, like these two terms, kind of box them out here, and leave them on one side and pull everything that does have a dy dx to the other side. So let me start by just writing those terms. We've got, I like to have the x come first with the number. So 2xy cubed plus 3x squared y squared. So those two terms. And I'm going to pull everything else to the other side. So dy dx was already there. Then this term would be subtracted, as would this term, to the other side. So we'd have minus 3x squared y squared dy dx minus 2x cubed y dy dx, like that. Then we factor a dy dx out of each of those terms. Leaves us with 1 minus 3x squared y squared minus 2x cubed y equals 2xy cubed plus 3x squared y squared. And then we divide both sides in order to isolate the dy dx, like this. And this is our derivative. So that's a lot of work to get to that, but that's how we do the derivative. Okay? Next, you'll see this one is going to obviously take some chain rule. All right? Because we've got this function being placed inside the sine function. So derivative of sine is cosine. Leave the inside alone. Then multiply by the derivative of the inside. Well, the derivative of 3x is 3. The derivative of 4y is 4 dy dx. I've run out of room here, but let's just think about here. The derivative of x is 1, so this will be equal to 1. Okay, now I want to get dy dx by itself. Now you have a number of options here. I think the way to make it the cleanest is to take this term and multiply it in like that. So you'll have, 3 cosine of 3x plus 4y plus 4 cosine of 3x plus 4y dy dx equals 1. And then you can subtract this term and divide this term to isolate dy dx. So your answer comes out to be something like 1 minus 3 cosine of 3x plus 4y over 4 cosine of 3x plus 4y. I think that's the easiest way. There are other methods, but I think that would be your easiest way to isolate. So again, we got a lot of little things to remember about derivatives, so this is just kind of an intro.